Work is done on an adiabatic system due to which its velocity changes from 10 meter per second to 20 meter per second. Elevation increases by 20 meter and temperature increases by 1 Kelvin. The mass of the system is 10 kilogram. Specific heat capacity at constant volume is 100 joule per kilogram Kelvin and the gravitational acceleration is 10 meter per second square. If there is no change in any other component of the energy of the system, the magnitude of the total work done in kilojoule of the system is, so from the steady flow energy equation, we know steady flow energy equation from here we can write m times per unit mass we are writing, so H1 enthalpy at location 1 plus V1 square by 2 plus G into Z1 plus Q. The heat transfer of the system is equal to m times H2 plus V2 square by 2 plus G into Z2 plus the work done by the system. And we also know that the enthalpy H can also be written as the summation of the internal energy plus P into V, okay, where 1 represent the initial condition and 2 represent the final conditions, okay, of the system. Now this steady flow energy equation can also be written as m times of U1 plus P1 V1 plus V1 square by 2 plus G Z1 plus the heat transfer in the system into is equal to mass times H2, we can write U2 plus P2 into V2 plus V2 square by 2 plus G into Z2, this is 2, plus the work done by the system W, and we need to find this quantity. Now in the problem there are several quantities already given, so let's write those. So it's given that V1 is equal to 10 meter per second, V2 is equal to 20 meter per second, Z2 minus Z1 is equal to 20 meter. The change in temperature delta T, which is T2 minus T1, final temperature minus initial temperature, that is 1 Kelvin, and mass is 10 kilogram. Okay, so substituting these quantities in the steady flow energy equation, we can write. So let's write here. Let's arrange this equation first. So W, we need to find the work done, so it can be arranged as mass times V1 square by 2 minus V2 square by 2 plus Z1 minus Z2 into G plus U1 minus U2. Okay, this P1 V1 and P2 V2 will be equal to 0 because it's also mentioned that any other component is equal to 0 other than what is given in the problem. Okay, also we know that internal energy of the system U can be written as CV into T. Okay, so if we substitute, that is specific heat capacity at constant volume into the temperature, and if we substitute it here, so let's write W will be equal to mass, which is 10, times V1, which is 10 square by 2 minus V2, which is 20 square by 2, okay, plus Z1 minus Z2, so it will be negative 20 into G, which we have to consider 10 meter per second square, plus CV we can take common, and the value of CV in the problem is 100 into T1 minus T2. So T2 minus T1 here is 1 Kelvin, so T1 minus T2 will be negative 1. Okay, so from here we'll get W is equal to minus 4500 joule or minus 4.5 kilojoule. Okay, that means the work is done on the system. Okay, because we are getting negative value of work, that means the work is done on the system. Okay, if there is no change in any other components of the energy of the system, the magnitude of total work done on the system is, so this will be 4.5 okay kilojoule. On the system itself means negative. For more information, you can refer to the NPTEL course lecture number 22, first law of steady state steady flow process on concepts of thermodynamics by Professor S. Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.